Okay, so that would make the Earth spinning this way, like so. It's rotating around. Okay, so you are on the equator, and on the equator, you are standing up like so, and you're looking this way towards the east. And if you get far enough around, you'll see the sunrise in your eyes, okay? So that's how you are on your ball there. All right, so now, this is your horizon. As you're spinning around on the Earth, getting towards the sunrise, you cannot see any of this level at all. You cannot see any of it. You can only see, your view right now is everything above it. You're looking up at stars. You're looking at the stars. You can see everything above it. You cannot see the level itself or anything below it because that is your ground. That's your horizon right there. You can't see beyond it. This is the terminator line. This is all daylight. This whole side of the Earth is dark. Okay, so the sun will light half of the ball equally, no matter the 23.4 degree tilt or what season it is, no matter when or where, the sun is always lighting exactly half of the ball. Okay? So now you're coming around. Remember, you can't see anything below this top ledge here. So as you're coming around, let me move it up here a little bit. You're spinning around on your Earth. All right, you get, okay, so I don't know if you can see it, you could get right to the terminator line there. Now, let me drop, look at the middle bubble here. Right there is horizontal, okay? As in horizon. Here, let me get it, I'm gonna just slide it up so it's right on the top of your Earth there. So you're standing there on the Earth. You cannot see anything below this line. You can see just out here and everything above it. You can see the sky. That's it, okay? When you get too horizontal, you can't see the sun at all. You can only see above this line. You definitely can't see the moon, all right? So that's the first one I wanted to address. And before you even get to how you can't see the sun and moon together, when you are looking at your horizon, you wouldn't be able to see the sun because it's in the center. It's aligned with the center of this ball. It's not aligned with the top of the ball. The sun's not up here. When you got the terminator line right here, the sun is aligned with the center of the Earth, lighting half of the ball. The sun's got to be directly down the middle.
Okay, we'll have a look at Mr. Boll's claim that Mr. Stellarium here at the top cannot see anything below the horizon. And Mr. Boll is right. I removed the ecliptic line because now the ecliptic is the same as the flat board it's being drawn on. Got rid of the polar view because with the equinox solstice we can have a variation of 23.4 degrees. So I just loaded the observer's point of view. So the question is, how does Mr. Stellarium at the top of the globe here see the sun and the moon if he cannot see below the horizon? The answer is because the sun and the moon are drawn to the correct angular width to what the observer sees in the sky, both about a half a degree in size. So if a drawing is not to scale, and you're drawing what you perceive, then you have to apply the laws of perspective. Much like what we see in a picture of a train track or a drawing of the same. So we can load a picture of a railroad track to show the perspective. We can place the Earth and the sun and the moon with the same angular size on the railroad track. Now Mr. Stellarium standing on top of the globe or the bottom, they would both see the same thing. Virtually, there'd be a little bit of parallax. So if you're drawing a perspective drawing, the lines must meet at a point. Your horizon straight line only applies if you're drawing everything to scale. Okay, from the basic laws of perspective, we can see this blue straight horizon line would only be valid when objects are drawn to scale, and not from a point of view perspective. This explains why Mr. Stellarium at the top of the globe can see the sun and the moon set, while Mr. Stellarium at the bottom of the globe can see the sun and moon rise. Don't see any problem with Mr. Boll's planned experiment of doing a scale model of the moon, the sun, and the earth. And here he can draw his straight horizontal line. He doesn't have to worry about a 200-foot ice wall somewhere out there. He can just draw a nice straight line and everything should show properly. I wish him the best of luck at this experiment.